The topic I intend to discuss is the raw data format of AC analysis in LTspice result. If we open the raw data in text editor, we can see the two parts in the raw data. As we have discussed in previous lectures, the first part is header, the second part is binary data. Similar to transient simulation result, there are two important parts, header and the binary data. Header gives a lot of information about the simulation setup. For this case, this is AC analysis. The flags are complex, forward, log, no compression. Number of variables are 3. Number of points are 101. Offset is 0. Command remains the same as Linear Technology Corporation LTspice 17. Variables are number of 3. Variable 0 is frequency. Variable 1 is V in. Variable 2 is V out. Binary data is still unreadable, and the format is explained here. For AC analysis results, frequency is a 8-byte plus 8-byte format. The data format is 8-byte for real part and 8-byte for imaginary part. So this is the illustration of the data format. First, we have frequency 1 with 8-byte plus 8-byte, followed by real part in 8-byte and imaginary part in 8-byte. After that is the second frequency and the real and the imaginary parts associated with this frequency, and so on and so forth. Now let me show you a quick demo. First, make sure you are in the correct directory for this lecture. We open the Python code given for this lecture. You can see there's only one single cell. The first line is to import LTspice 3 as a module. We use the same sim data. We use LTspice 3.sim data to import the raw data. The name is AC_LPF.raw. The data is saved as in SD. SD.variables give the name of variables. SD.values gives the frequency and complex numbers in AC analysis. The first index gives the frequency. The rest of the index of values gives the traces in complex numbers. Let me remove all variables. We can just use this button to run the file or use F5. The code has been implemented. The first variable name is frequency. The type is complex 128. The size is 101. There are 120 and 1 frequency points, starting from 1 Hz all the way down to 100 kHz. Frequency underlying complex variable is a list of 3 NumPy arrays. Double-click the NumPy arrays. You can see the first element is just the same as frequency. The second element is input voltage. Because the input voltage is AC voltage at 1 volt, so it remains as 1 volt over the entire frequency. The third element has index number 2, which is the output voltage. It is a complex number. If you change the width of this cell, you can see this is a complex number, and it's changing as frequency changes. The name of these variables are frequency, input, and output. This is the complex number of all traces, named as trace underlying complex. This is just input voltage as a complex number and output voltage as a complex number. Here's a reference for this lecture. Thank you very much. See you soon.